Hello and welcome back, everyone. Today we're going to hit section 6.3, properties of trig functions. This one is a big one. You really want to spend some time with the material in this section. This is something you're going to be using not just throughout this course, but really through several more courses to come after this. I'll just abbreviate the trigonometric to trig. So really try to spend some time on this. If you need to pause and rewind the video, do lots and lots of the practice problems. These are some important things that are going to keep coming up. So we'll start with domain and range of trig functions. So we'll consider y equals, we'll start with just the sine function. Y equals sine theta. So theta is sort of acting as our x, so we'll call that our domain. And you can take the sine of any number you want. So our domain for that one, negative infinity to infinity. You pick out a real number, you can take the sine of that real number, your favorite number, your address, your age, any number you want. So sine theta on the unit circle is y over 1, or just y. Cosine theta on the unit circle, x over 1, or just x. Again, any value that we want, negative infinity to infinity. However, the tangent of theta, remember, is y over x. So x has to be non-zero. So we have one domain restriction. So basically negative infinity to 0, union 0 to infinity, open parent on both zeros, if you want to see it written out the long way. Cosecant theta, remember that is the reciprocal sine, so that is 1 over y, so y is non-zero. Secant theta is a reciprocal of cosine, so x is non-zero, and cotangent theta is a reciprocal of tangent, so x over y, so y is also non-zero for that guy. Now, with respect to turning those into angles, on the unit circle, I'll just make a quick rough sketch of the unit circle here. Ooh, that one is way off balance. Again, a little imagination, and go 1 unit in each direction from the origin. X equals 0, that's happening up here at 90 degrees, so pi over 2. Down here at 3 pi over 2. And we could keep spinning. Remember, we're allowed to make more than one revolution around the circle. So also at 5 pi over 2. 7 pi over 2, and so on. Now, since we can also spin backwards, this would be not just 3 pi over 2, but also negative pi over 2. We can put a plus or minus in front of each of these guys. And so our general one would be plus or minus 2n minus 1 pi over 2. So 2n minus 1 gives you an odd number. For example, plug in a 1, 2 by 1 is 2, 2 minus 1 is 1, plug in 2 for the n, we have 4 minus 1, 3, the next odd, and so on. We also want to look at where y equals 0. That happens at theta equals 0. Y values are back down to 0 at a half circle, so pi, 180 degrees. Another half rotation, and we're at 2 pi, 3 pi, 4 pi, and so on. And just like the x's, we're allowed to count backwards as well. So plus or minus for these guys. 0, of course, is neither positive nor negative. So the general term for that one would be n pi. So those are the sort of domain values, the angles that we're allowed or not allowed to use for some of these. So sine and cosine, we can use anything. Tangent and secant, we can use anything not in this list. Cosecant and cotangent, we can use anything not in this list for our angles. As far as range values, since we're on the unit circle, sine theta, the y values are stuck between -1 and 1. The lowest we can go is -1, and we are allowed to reach that. Highest we can go is +1, we can't reach that. Similarly, cosine, I'm between -1 and 1. You can even sort of shorten the notation using absolute value. Cosine, I want to shorten it so much that I forget theta. Cosine theta inside of an absolute value less than or equal to 1. So that still implies between -1 and 1 for the cosine values. And all of the other ones, remember, are built off of those first two. So our tangent, y divided by x, well, since x can start getting closer and closer to 0, if your denominator gets close to 0, your end result gets bigger and bigger. So we can approach infinity. Y can actually reach 0. 0 divided by some non-zero number is 0. And since x and y can have different signs in, for example, Q2 and Q4, they can have opposite signs. We can also have negatives involved. So tangent theta really can take on any value. So tangent theta, the range would be just -infinity to infinity. Any real number at all can be a range value for tangent. Now sine's reciprocal, which remember is the cosecant, we'll look first at this first half circle up here. So 0 doesn't have a reciprocal, but anything other than that, we're looking at a positive proper fraction or 1. The reciprocal of a proper fraction, so little number over big number, is an improper fraction, which is greater than 1. So cosecant theta, the minimum that can be is 1. Again, on the top half. If we're on the bottom half, we're doing the reciprocal of a negative proper fraction, which is a negative improper fraction. So we union that up with the possibility that the cosecant theta could be less than or equal to a negative 1. And you can make similar arguments as far as cosine's partner. So positive cosine, negative cosine, we're either at 0, doesn't have a reciprocal, we're undefined there. Proper fraction reciprocal is an improper fraction which is bigger than 1. So the secant of theta is either at least 1 or less than negative 1. Less than or equal to negative 1. Cotangent, much like the tangent, any numerical value. Any ratio is possible. Alright, so next up we talk about the period of a trig function. So if you recall, 2 pi is 1 full revolution on the circle, so for sine and cosine and their partners cosecant and secant, 2 pi is 1 period. So if you go from 0 to 2 pi, you've seen everything that that function can do. If you have, for example, sine theta or cosine theta, 0 to 2 pi will show you everything it can do, and then it starts again. 2 pi to 4 pi, it will go one full rotation of everything that it does. Now, tangent and cotangent, however, those have a period of pi. Now the reason for that, you want to think in terms of quadrants. So for example, we'll just do the nice, neat, pretty 45-degree angle, the pi over 4. Sine and cosine are the same, so tangent and cotangent would both give you a 1 there. Well, sine and cosine are the same also down here, 45 degrees past the 180-degree mark. So that would be pi plus pi over 4. So at 5 pi over 4, the same thing happens. Sine and cosine are the same, so their ratio is still a positive 1. So the same thing is happening in Q1 and in Q3. Same deal would happen Q2 versus Q4. So here, cosine is negative, sine is positive. Here, cosine is positive, sine is negative. So you don't have to go as far to see a full revolution of what tangent or cotangent can do. So in other words, what we know is that the cosine of theta plus 2k pi is the same as the cosine of theta. So in other words, 45 degrees or 45 degrees plus 1 full revolution, or plus 2 full revolutions, 3 full revolutions. K can be an integer, so also backwards 1 full revolution. You're still landing at the same x value, and the other 4 have similar properties there. Sine of theta plus 2k pi, that's a messy pi, sorry, is the same as sine of theta. Secant of theta plus 2k pi is secant theta. Cosecant of theta plus 2k pi is worth cosecant theta. And for tangent and cotangent, instead of 2k pi, we just need k pi, since it's just pi for a period for a tangent or a cotangent. So each of those would be equal to the original theta, tan theta, or cotangent theta. And for all 6 of these, k is an element of the integers z. All right, pause it here. We'll have some practice problems in the next part.